Good early evening to everybody. I hope you can all see my screen. Is that right, Kathy? Okay, great. We are here today to discuss reconsidering what's possible and how we can make adaptive reuse make more housing. We put this topic together as an opportunity to speak at the AIA Design Conference in Bend this year, and found that it would be better served as a digital design series. And so we are excited to have the opportunity to present to you all today our thoughts as a group here on adaptive use and housing. So just some quick introductions so you know who will be presenting today. My name is Haley Purdy. I am a principal at Scott Edwards Architecture. I have been working here at Scott Edwards in the field of affordable housing, transitional housing, a lot of nonprofit and community-focused work for over 9 years now. I have had the pleasure of working with this very accomplished team that I'll let them introduce themselves and then do a quick summary of the two firms, and then we'll get going. So without further ado, Sarah?
Hi, my name is Sarah Rusenberka. I'm an associate principal at Scott Edwards Architecture. I've been in architecture for over 16 years, over 11 of them at SEA. And much of my career at SEA has actually been spent on adaptive reuse, or as we lovingly call them at the firm, messy projects.
I'm Rebecca Littman-Smith, also an architect at Scott Edwards Architecture, where I've been able to work on quite a few adaptive reuse projects, including 2 of the projects presented today, along with Carl from KFSE.
Hi, everyone. I'm Carl Close. I lead the Portland office of Kurt Fisher Structural Engineering. In my 20 years of experience, I've been fortunate to work on many adaptive reuse, seismic retrofits, multifamily, and affordable housing projects. And I'm excited to share my experiences in the hope that it'll help others that are working on adaptive reuse projects.
Scott Edwards and KFSE have done quite a bit of work together on adaptive reuse work. And when we were preparing this topic for presentation, Carl and all the work that FSSE and SEA have done together, as well as the extensive work that KFSE has done in California, really came to mind, and we thought there would be no better team member than Carl to be on this presentation. And so it's our pleasure to be all here together with you and presenting. Scott Edwards has been very much at the forefront of affordable housing and adaptive reuse here for quite some time. This team comprises a very experienced group of professionals that have done housing in all sorts of formats, as well as adaptive reuse. And so we'd like to really emphasize that experience and that knowledge base here as we begin to talk about using adaptive reuse as a process to actually increasing housing and addressing the housing crisis. So adaptive reuse. Today, we want to talk about our shared experiences with adaptive reuse on existing buildings and their transformation to housing. Why do we want to talk about this? It's because adaptive reuse promotes sustainability, it bolsters jobs, it supports existing neighborhoods, and we want to present to you today 5 successful case studies, the projects which you can see in the images below, that discuss the pros, the cons, our successes, our challenges of adaptive reuse to housing. We're going to share some of those challenges, the opportunities, importantly, the advocacy work that was done to support those adaptive reuse projects, and some inspiring stories of those projects so that you can all hopefully keep them at the forefront of your mind as if you find yourselves going into the opportunity to develop an adaptive reuse project that would lead to housing. We know as architects and engineers that often some of the most important information gained is that of a lesson learned on a project, and there are plenty when we talk about adaptive reuse to housing. So without further ado, the why of adaptive reuse to housing. The first why is the conversation of sustainable benefits of adaptive reuse. When we compare adaptive reuse of an existing building to that of a new building or new construction and the tear down of an existing building, the sustainable benefits are quite clear. So the sustainable benefits for an adaptive reuse renovation are listed on the right side of the screen, and the advantages and disadvantages of a tear down rebuild are on the left-hand side. So from a high-level overview, we know that adaptive reuse can be a low energy use development and construction. It offers lower embodied carbon. I'd love to go into depth about what that really means. We don't have time for that today, but please note that that is a really important quality of adaptive reuse from a sustainability standpoint. It offers significantly lower demolition waste, often more affordable rents, preserves a neighborhood character. It helps to maintain existing businesses. We also know that one of the things that is not so great at is that often we cannot increase density if we are doing adaptive reuse. Density is often a really important component in affordable housing, is creating greater density. That's something that adaptive reuse doesn't always typically do. We also know that a lot of times some of the challenges of adaptive use can be the ADA, seismic, and life safety challenges that come along with those types of developments. We also have to often deal with the challenges of deferred maintenance on a building that is being adaptively used. And we also know that from experience that for us to be successful in an adaptive reuse conversion, we have to have extensive records and documentation of that existing building. That is one of the challenges. So one of the main reasons why adaptive use to housing is such a wonderful process is because it has a significant reduction to climate impact. So what does that mean? I know a lot of us have probably heard that discussed as one of the benefits to adaptive reuse. The high level overview of that is that building materials and construction are responsible for 40% of the global carbon emissions, more than any other sector. With that in mind, when we look at the structure and the envelope for accounted for 50% of a building's embodied emissions. If we do adaptive reuse, what we're finding is that we can reduce those embodied emissions by anywhere between 50 to 75%. That's enormous. And it can make a huge impact on the actual sustainable impact that a project and its development can have. In addition, like I said before, we acknowledge that adaptive reuse can bolster a local economy. When we compare new construction, adaptive reuse is more labor intensive rather than material intensive. So why does that matter? It matters because every dollar that we spend on labor creates $2 to $3 for the local neighborhood, while every dollar spent on materials yields less than $1 for the community. Something that I never really thought about a lot when we were talking about adaptive use, but it really is impactful. And it's something that we need to keep in mind, especially if we're talking about the adaptive reuse of of a building to affordable housing. And then third, supporting neighborhood fabric. Existing buildings preserve that neighborhood fabric and that character. They're working with the existing vernacular that was already there, and we're refreshing it and re-envisioning how that could be working within the existing fabric. A renovation and reuse may allow for maintaining existing businesses, and importantly, a lot of times the renovation and reuse will support more affordable rents than that of a new construction. That it can be important, like I said, also for affordable housing and for those projects that really are just barely making the line of being profitable. So without further ado, I'm going to let my team member, Sarah, talk about one of our first case studies from a hotel motel to housing conversion. Sarah?
Thanks, Haley. So as Haley mentioned, we want to share our experiences with adaptive reuse housing conversions and hopefully get you excited for what's possible with our current building stock. A reality of adaptive reuse is that each of these projects will be unique. The buildings are unique, the programs are unique, communities are unique. The first adaptive reuse conversion that we're going to discuss is the hotel motel to housing. Many of you know these became critical emergency housing resources during the pandemic, and many have continued to be developed as adaptive reuse through funding programs such as Project Turnkey. Benefits of the hotel motel to housing conversion include the individual rooms make conversions easier. State programs have been available for funding. They often exist in areas offering good walkability and proximity to public transit. And some of the challenges of these are that the length of stay will often result in a change of occupancy. Utility loads for independent units are much larger than hotel motel use. And other programmatic components are tight, both in the individual units as well as in the building. And accessibility upgrades are often a challenge as well. And I'm sure there are a variety of additional benefits and challenges. Those are a couple of quick ones that were really apparent and obvious in both of the case studies that we're going to look at. So today we're going to explore a few of the case studies with this type of conversion. Our first one is Casa Amparo, which is a partnership with nonprofit Centro Cultural and is located in Forest Grove, Oregon. Casa Amparo was actually SEA's first adaptive reuse housing conversion. The existing building was constructed in 1991 as a 20-room motel with a caretaker unit. SEA began the design on this project back in 2021, and phase 1 scope was actually just completed in October of 2023. Next slide. It became clear in our initial discussions with Centro, they had big ideas for Casa Amparo, and as is often the case, a relatively modest budget. Though we don't always think of master planning for smaller projects, our experience has shown giving space to work through a full range of ideas can help guide the project. Master planning was a very successful tool in this case to establish project goals and at a project of any size, and let the owners explore all of the things the project might want. We worked with Casa Amparo on an expedited timeline and minimal fee to explore their ideal project, considering the community that they had planned to serve. In parallel, we worked with our consultant partners to better understand the existing building systems, resulting in a more accurate budget. Partnering with a contractor upfront, we were able to get a high-level budget for the owner to determine whether the full scope would be able to be realized. You go to the next slide. It's probably no surprise to anyone on this call, but the initial effort resulted in a cost that exceeded the budget and required securing additional funding. In spite of the owner's efforts, they weren't able to secure additional funding in the amount of time that was required for them to actually adopt their initial funding source. And because of this, we had to scale back the initial project scope. So because of the initial due diligence and master planning efforts, SEA and the design team were able to help the owner realize their priorities based on their budget. A phasing effort was critical in understanding what should be prioritized to serve the immediate community needs and what should be accommodated if future funding could be secured. For this project, we identified priorities in 4 digestible buckets, including maintenance, units, community spaces, and exterior, allowing Centro and their stakeholders the opportunity to evaluate the immediate needs against their budget. Next slide, please. It was determined the critical needs for the building were surrounding longevity, safety, accessibility, and the user experience. We completed phase 1 in October of 2023, upgrading the stair access to the 2nd level, walkways, adding space for tenant cooking and laundry, adding fire sprinklers, and upgrading the accessibility. Through the master planning and phasing efforts, Centro was able to clearly identify and articulate their top priorities, including facilitating tenants' independence and providing support for families. They are now close to securing funding for these efforts and anticipate a formal design effort to begin in the next few months. Rebecca and I actually worked on the first phase of this project together, and she was able to take some of those successes and lessons learned from this project into our second case study, which is Family Promise.
So Family Promise was an existing 4-story hotel in Tiger that's now owned by Family Promise of Tualatin Valley. The conversion from a hotel occupancy to a transitional shelter serves both individuals and households for up to 4 months. Family Promise's mission is to equip vulnerable families and individuals to end the cycle of homelessness through a community-based response. The project team worked to support the mission and provide communal spaces for the new residents, in addition to the new sleeping units. Project funding from the state of Oregon included Project Turnkey, funding from the city of Tigard and Washington County. Due to limitations with the existing building, the design team, including Carl, worked to consciously avoid triggering a seismic upgrade by keeping alterations of the seismic force resisting system to a minimum and not crossing the 10% threshold allowed by the OSSC. With a change from R1 to R2, the building will be fully sprinklered by the end of construction, which is estimated to be in the middle of 2025. Next slide. So the ground floor, as seen in the slide, has the most significant alterations. The part of the floor will remain as sleeping units. That's the pink. And there are significant spaces that are dedicated to program staff, offices, resident support, a multi-purpose room, a resident laundry space, and a playroom. The shared resident laundry is connected to the playroom, allowing for parents to have visibility to kids playing while doing laundry. And in orange, we have a community dining room, and in yellow, which unfortunately did not get labeled, is a commercial kitchen. The approach for this project was to take a more community-based approach to dining, and that they provide meals for residents free of charge, and that meant that the former hotel rooms were not altered to include kitchenettes. This provided a cost-effective solution for addressing an item that would have had significant mechanical, electrical, and plumbing requirements that the building would not have easily supported, in part due to significant limitations to the floor-to-floor height. This building structure has a floor-to-floor height of approximately 8'6". The second and third floor, which I'm not showing you the plans of, are, the second floor will be a mix of staff offices for case managers, staff, and volunteers. The third and fourth floor, which are also not shown, will be a mix of staff offices for case managers and volunteers. I feel like the audience can imagine what the upper floor plans look like with a double loaded corridor with a lot of hotel rooms that are now sleeping units or in process of being sleeping units. So the next slide, one thing we found was that Family Promise wanted to open and use the building almost immediately. And so that was a major hurdle, that the building was going to remain occupied during construction. The team includes Remick Construction, and they have been incredibly helpful to help figure out a way to phase the rotation of residents so that they can maintain services to all of their residents. As the hotel capacity originally was over 100 rooms, and this building will serve up to 70 households. During the conversion period, they'll be able to use rooms to rotate the resident groups and blocks and ensure that every single room gets sprinklered. The site is a little bit suburban in Tigard, and so it includes a significant parking lot area. And while that's not shown in this diagram that shows the phasing, the parking lot provides significant space for staging and storing materials outside the building, which also helps with the phasing and sequencing. As Sarah kind of alluded to, there are definitely some goals for both Casa Amparo and Family Promise where they have things in common. They both wanted a playground in addition to an indoor play area. They both needed sprinklers, but there are significant differences to how they approached access to food and kitchens and the community spaces. Family Promise also includes a multi-purpose room in addition to the indoor playroom, as they have a lot of volunteer-led programs for education, workshops, and after-school tutoring that help build community and also give the residents the support to transition to more permanent supportive housing. And I will pass it over to Carl now.
Thanks, Rebecca. First off, I'll discuss office to housing conversion projects. For the benefits of office to housing conversions, of course, there's the aforementioned reduced embodied carbon by reusing the existing structure. The buildings often exist in areas with higher density and can provide good walkability and access to public transit. They can help to reinvigorate a neighborhood by taking underutilized or vacant buildings and providing a better use for the building. If the building is historic, it can aid in historic preservation by giving new life to the old building. And depending on the jurisdiction, a seismic retrofit may be required, which will provide improved seismic safety for the occupants of the building and improved community resiliency. Of course, the seismic retrofit is also a challenge, as the cost of the retrofit can impact the project economic viability. Other challenges include the conversion of the MEP systems to the new residential occupancy and the coordination of those systems throughout the building. Egress can be a problem, especially for older buildings with only one internal stairwell, and ADA accessibility upgrades can be difficult to accommodate as well. Our first office to residential case study is the Woodlark Hotel in Portland, Oregon. First off, I want to thank Ted Grund of MCA Architects for the use of MCA's drawings and providing input on the architectural aspects of the project. The project involved the conversion of 2 buildings that are on the National Historic Register. Most of my discussion will be on the Woodlark building, which is on the left, which was an office to R1 conversion. The adjacent Cornelius building is a 7-story unreinforced masonry building, which underwent an R2 to R1 conversion and full seismic upgrade. While not an affordable housing project, the Woodlark is a residential conversion and would entail some similar challenges, such as fire rating and code issues, a seismic retrofit, and MEP needs for residential use. The Woodlark building was designed by A.E. Doyle in 1912 and consisted of 9 stories of reinforced concrete with a ground floor mezzanine. It was originally a retail drugstore, though it was converted to an office building in 1924. The adaptive reuse project was completed in 2018 and won awards, including a DeMuro Award for Historic Preservation, and was named one of Time Magazine's Greatest Places of 2019. There are a lot of challenges with a project involving 2 historic buildings, and acceptability in the building code may not be clearly defined for many situations. This project included 27 approved code appeals, many dealing with archaic materials and fire life safety issues for the historic buildings. One of those challenges and approved code appeals involved providing 2 egress paths. Given the small floor plates, providing 2 means of egress for each building was not possible due to the loss of building area on each level. The team had a radical solution of connecting the 2 historic buildings so that the 2 egress paths could be provided without adding a new stairwell to either building. You can see the markup in the middle showing the corridors in yellow, with the stairs in green and the elevators in blue. This was not an easy solution. The buildings had 2 different construction types, type 1A for the Woodlark versus 3B for the Cornelius, though that was converted to 3A. None of the floors aligned. The Woodlark had 3 more stories than the Cornelius building, and the connection would require careful seismic detailing for the seismic drift compatibility at the connecting stairs. To provide the connection between the buildings, you can see on the right there, we have a structural section which shows the Cornelius building highlighted in orange and the Woodlark building in green. You can see that each stair run had a different height, and we had to use different seismic slip details, as some of the stairs went from the Woodlark to the Cornelius and some went from the Cornelius to the Woodlark. And so there was a lot of very careful detailing to accommodate this solution. Another challenge was the conversion to a high-rise. Our client had a strict requirement for 150 keys for the hotel, which necessitated infilling the existing mezzanine that was at the ground floor of the Woodlark building to create a new second floor. By infilling the floor, the building area was added, and also a new story was added to the building without any change to the existing building height. And this triggered high-rise provisions for the structure. This then required an elevator lobby, fire command room, larger Gurney-compliant elevators, and a backup emergency power source. The elevator lobby was difficult to make fit with the corridors and room layout. To accommodate that layout, the team moved forward with a custom elevator cab, which worked great with the corridor layouts and room layouts. However, when the price of that custom elevator cab came in, it turned out that it was cost prohibitive. So the elevator was switched to a stock elevator mid-construction, which required a change to the whole elevator core, and thus caused modifications to the seismic force resisting system, which consisted of concrete shear walls around the core and a full redesign of the seismic force resisting system in mid-construction. The seismic upgrade was a full 100% a new code force level retrofit. The lateral system, next slide. The lateral system was a new specially reinforced concrete shear walls, which were provided at the interior to preserve the existing windows and facade. Here you can see one of the details for a concrete coupling beam at the elevator core, and also an image of the wall under construction. Detailing of the wall, especially how the wall interacts with the existing floor plates, was critical for the success of these shear walls, as there had to be a lot of coordination with the contractor working through how to both maintain adequate structural performance of the walls, but also have a solution that was buildable. One other challenge was with the retrofits was it's called building pounding, which is when two adjacent buildings collide. And to account for this, the team increased the seismic design force level for both buildings, and then also introduced a backup gravity system of concrete pilasters that would provide a gravity support in case the existing masonry walls of the Cornelius were damaged. Another critical element for the retrofit was the foundations. The existing foundations were deep foundations consisting of belled caissons that extend 20 feet below the basement. One approach could have been to introduce new micropiles below the new concrete shear walls, though for this project, our solution was to instead provide very large outrigger grade beams that would reach out and grab as many of the existing belled caissons as possible, which would then distribute the overturning seismic loads. And by doing this, we were able to provide a solution that had no new deep foundations. As you can see, some of these outrigger grade beams were just absolutely massive. There's about 6 feet 6 inches tall, over 5 foot 6 inches wide, and you can see a person in there for scale. But by distributing the load, that was critical for the project's success by eliminating the need for micropiles and the costs associated with those. Another big structural challenge was that there's an existing transfer beam at the third level, which introduced 2 columns below the third level, and neither of those columns worked with the unit layout or corridors. So the project team challenged us to find a way to remove those columns, replace it with one central column, which we found a way to do that. But the key to this was really coordination with the general contractor, Pence Construction, and going through sequencing, trying to find a solution where this could be built without requiring full building shoring, which would have been a nightmare for the construction team to have to work around during construction. And then in the end, we did find a solution that did not need any building shoring and allowed for the removal of these 2 columns. The next project that I'll cover is 222 West 6th Street in San Pedro, which is part of Los Angeles, California. For this one, I want to thank Tara Bibi and Rodrigo Zayas of KFA Architecture for their assistance and the use of their renderings. The project involves a 13-story office building that was built in 1988. It will undergo a conversion from B occupancy to R2 occupancy, providing 228 units of market rate housing. The floor plate is approximately 110 feet by 210 feet, which created a difficult unit layout due to the long depth from corridor to exterior. The longest units have a depth of 56 feet and required considerable thought in the tenant's experience related to natural light and ventilation. The project is currently in plan check and undergoing a City of LA required peer review process due to the specialized seismic analysis. Some of the major improvements include the new rooftop deck and pool amenity space. New MEP systems are provided throughout the project. Also, there was the full code seismic upgrade and extensive facade updates that will be discussed on the following slides. We're already over to that one. The envelope For the envelope improvements, the existing wall cladding and glazing are being removed, though the existing metal studs for the curtain wall system are being retained and reused. There's going to be new glazing that's installed that is more energy efficient, and also openings that are going to be cut in the curtain wall to create the new balconies. These balconies are, the structure for these balconies consists of 12-inch deep HSS steel tubes that are attached to the exterior steel moment frames and have backspans back into the unit for stability. As mentioned, one of the big improvements and also challenges is providing a full code seismic upgrade. This upgrade is triggered due to the occupancy change and also the addition of the rooftop pool deck and amenity space. You can see the extents of the rooftop addition shown in purple on the diagram. The existing lateral force resisting system is a pre-Northridge steel moment frame shown in red. In the Northridge earthquake in 1994, this type of connection was found to have a defect, which can lead to a fracture of the welds, which can propagate through the columns and cause the columns to fracture. As part of the retrofit, this connection needed to be addressed. The solution that we are using is to install a fuse in the connection, which is shown in green, which is basically every one of the moment frame connections. Then we also have shown, however, when we ran the analysis, fixing the connections was not the end of it. There were still overloads in the lateral force resisting system. So we introduced fluid viscous dampers, which are shown in blue, which dissipate energy and reduce the seismic demands on the moment frames. To design the connection retrofit and damper system, we relied on a nonlinear time history analysis, which is a performance-based design that is more rigorous than conventional code-based approaches and involves subjecting the building to 11 earthquake ground motions that are scaled and chosen by the geotechnical engineer. And one of the great benefits of doing this analysis and using the existing frames with the dampers to reduce the forces at the base is that we were able to demonstrate that the existing piles and pile caps are adequate as is, and thus avoid very expensive foundation strengthening. On the next slide, here's an image of the Durafuse connection. We are slotting the existing beam and cutting the flange and providing this new plate configuration below, which has a fuse in it so that it'll protect the columns and prevent the overload of the welds and failure that is common in these older moment frame connections. Next slide. This project would not be happening without the City of Los Angeles Adaptive Reuse Ordinance, which was passed in 1999 with updates in 2002. To incentivize the conversion of vacant and underutilized buildings in downtown Los Angeles. The Adaptive Reuse Ordinance has been a huge success, creating more than 12,000 units in its first 15 years. Some key points about the City of LA Adaptive Reuse Ordinance. One of the main ones is that adaptive reuse is by right. So there's no design review, zoning review, or CEQA environmental review. Also, since we're talking a lot about affordable housing, these conversions are still subject to LA's inclusionary zoning rules. So there will be either 10% of affordable units provided or funds placed for new construction of affordable housing. There's no new parking that's required. And also the roof deck is allowed by right. LA is in the process of updating their adaptive reuse ordinance for the current needs to expand it citywide and to add incentives. One really interesting new incentive that they're looking at is for affordable housing projects specifically, and they will allow 2 new stories to be added without counting that as added floor area or added stories. Many other jurisdictions also have provided incentives that show that they welcome adaptive reuse projects. In particular, Long Beach, California, and San Francisco also have ordinances that promote adaptive reuse. And I've heard that Seattle is also considering an ordinance. And additionally, the state of California has a bill in their legislature right now that is considering making a state law that adaptive reuse would be allowed by right. And I know there are folks working to make adaptive reuse projects more feasible, in Portland, and just wanted to point out that there's some very good examples of successful policies in other West Coast cities. Now we're going to change gears to a different non-traditional typology for adaptive reuse, which is a supermarket to housing adaptive reuse. Part of this presentation, we all want to spur conversation around adaptive reuse and encourage everyone to think creatively about potential adaptive reuse projects. Some of the benefits of this type of conversion are similar to office conversions, with the embodied carbon savings and also often good locations for walkability or transits, and the improved seismic safety when the building is retrofitted. Challenges include the cost of the often required seismic upgrade, and also the unit configurations and providing natural lights. For our case study, I'll present the 1355 North Avalon project, which is located in Wilmington, California, which is also part of Los Angeles. And first of all, I want to thank Brad Leeds of KFA Architecture for the use of their renderings in this presentation. The old supermarket, which was built in 1954, is smaller than current needs for supermarkets and had been vacant for 10 years. The change of occupancy will be from a M occupancy to an R2 occupancy. Plus, there's a 24,000 square foot addition with of new construction of 4 stories, adding a total of 54 units of affordable housing, 50% of which of those are qualified permanent supportive housing. One of the challenges for this project was that it was originally envisioned as a modular project with prefabricated units within the supermarket space. Though early on in design, this was found to be not a viable option due to installation space and sequencing. Most modular units are installed with a crane, but this was not possible working below the existing bowstring trusses. Using forklifts was investigated, but in the end, the decision was made to switch to stick-framed units. Another challenge that the project faced was an unforeseen partial basement that was discovered during construction. This appeared to be from construction that predated the supermarket and was buried below the supermarket slab on grade. This discovery required a redesign of the foundations for the units during construction. And then next one. Here you can see a plan and rendering showing the existing and new construction. The new 4-story structure is shown in blue, with the existing structure outlined in red. The green indicates the new 1-story units within the supermarket space. The purple is the lobby, tenant services, including the community room and case manager offices. And the yellow shows the light well that was introduced by removing the roof sheeting. This new light well was key to the project's success, as it brings natural light into the space and provides a nice communal space for the tenants. Next slide, please. In the slide, you can see the existing bowstring trusses, which are exposed in the courtyard. These trusses also provide one of the project challenges, which was the repair of the trusses, which were damaged in numerous locations. Extensive site investigation and surveys of each truss was required to provide repairs for each unique damaged location. With the occupancy change and new diaphragm opening, a full code seismic upgrade was triggered. For the upgrade, new shotcrete shear walls were added to the exterior to strengthen the existing partially grouted CMU walls. New diaphragm sheathing was installed over the entire roof, and the anchorage of the wall to diaphragm connection was strengthened. And that wraps up my slide, so I'll pass it back to Haley.
Thank you, Carl. Frankly, I think we all could have spent like 3 hours on Carl's slides, Scott Edwards included, as we were preparing for this presentation. Rebecca, Sarah, and myself kept asking for more information from Carl. So I apologize that we didn't spend longer there, Carl, since we only have an hour. But I want to just acknowledge that all of those projects you presented were just incredibly interesting and involved. And I loved hearing about them 3 times. So thank you for that. So to summarize, you know, one of the things we do when we're preparing a presentation like this is really trying to come back to, like, why are we talking about this? We know a lot of people a lot of architects, a lot of engineers have talked about adaptive reuse in the past, especially adaptive reuse to housing, trying to figure out how we do it best. But it's worth acknowledging and coming back to why in the world are we still talking about it? And we're talking about it because we believe as architects, as engineers, that adaptive reuse projects are a critical solution to that future housing challenges that we're having. They revitalize existing stock and they provide sustainable building solutions. That's important to note, and it's something that we keep coming back to. In addition, the adaptive reuse helps to meet a need for more housing of all types. Just kind of like Carl was iterating, there was housing, there was affordable housing, there was transitional housing, there was also hotels. And so housing of all types, the need can be met with the adaptive reuse process. We also know that adaptive reuse can reactivate a vacant or underutilized building. We are dealing with this nationwide. It's something we hear about as architects and engineers, and it is a call to action, I think, for all of us, and it's something that we feel passionately about as a group, and we know that adaptive reuse can help to address that concern and that need right now with those vacant buildings across the United States. Adaptive reuse can also be considered a catalyst for development and the reactivation of neighborhoods, cities, nearby buildings, and public spaces. That can't be stated strongly enough, and it's something that we need to embrace as we advocate for adaptive reuse to housing conversions. And I think this should be stated strongly with the audience that we have today, that adaptive reuse should encourage developers, designers, and engineers to think differently. It should be challenging our creativity, and we can be open to new ways of living. All the examples you saw today would never have happened if it weren't through an adaptive reuse process. And frankly, I think some of these solutions that Rebecca, Sarah, and Carl presented were some of the most creative solutions to housing that I've seen in a very long time. It should be something that we should be embracing, is those opportunities for creativity and new ways that we can encourage people to live. So what do you need to do to remember as you set forth in these future opportunities and advocacy of affordable housing and for adaptive reuse process, as well as other types of housing like transitional housing or even market rate and hotels? You need to remember that your project team should be nimble. This is a nimble group here. Sarah, Rebecca, Carl, we're all fairly nimble. We know that these projects are not linear. We need to keep that in mind. It should be at the forefront of our proposals, of our contracts. We need to know that we put it together a team that knows how to be nimble. We need to establish those project goals and those priorities as early as possible. Sarah builds a mean schedule here at Scott Edwards Architecture, and you would not be able to put together a schedule for an adaptive reuse project that was in a traditional schedule. You would need to be mindful of all of those goals and priorities that we set out. Providing a full building assessment, early due diligence, and a committed project team as early as possible. These will help alleviate your future discoveries and challenges. Knowing the devil that you are up against is the most important thing you can do, and that is achieved with those due diligence studies and the assessments of those buildings. Adaptive reuse requires advocacy. It's something Carl touched upon lightly with Los Angeles and some of the other policies and ordinances that have been put in place in the state of California to encourage the development of housing and or adaptive reuse of existing building stock. We as a project team, as well as a call to arms for architects and engineers, need to be advocating for these different types of policies and ordinances that can lead to successful projects and spur development. We see a little bit of action here in the city of Portland, and we want more. And so we all need to be advocating for that type of development to encourage all of the reasons why we just acknowledge that adaptive reuse is important. And last but not least, all of these projects are unique. There was not a single approach to any of these projects that we presented today that filled a standard approach. We have to be ready to deal with the unknowns. Some of those challenges that I saw Carl present, especially about the woodlark, kind of mind-blowing. And it's an important thing that that you will be setting forth in a unique development if you do pursue adaptive reuse conversions of existing building stocks of any type to housing. So without further ado, we have a few minutes for questions, and we would like to open up the time for anyone to have questions for the four of us. Don't worry, I expected an awkward pause. Kathy?
I was just gonna say, if they're uncomfortable saying it out loud, they can put it in the chat.
Okay.
I have a question.
Jim would. Hi, Jim.
Hi. On one of the earlier projects you showed, I think it was a 4-story motel, and you just showed the first floor, and it looked like you had units like covering about a third of that floor. I didn't understand what you were doing upstairs, or if that was a second, third phase. At one time, I think I heard you say you were doing offices up there, but I wasn't.
I'll let Rebecca talk
Please
to that.
comment.
Yeah, absolutely. We didn't show the upper level floor plans. This plan of the ground floor shows like a typical unit layout on the left. It's sort of that lighter blue.
Yes.
Second floor, the former hotel rooms will be primarily used by case managers as staff support spaces for them to be able to support residents, and then some spaces for volunteer and a little bit of utility room. The third and fourth floors will be used by the residents. So they will primarily still be in their hotel room floor, but will be considered sleeping units. And the majority of the work in the third and fourth floor is upgrades to finishes and fire sprinklers.
Thank you.
You're welcome.
This is
I
Dave.
had a question. Oh,
A couple questions, pretty much for Carl on the woodlark again. Fascinating. It seems like all of these projects, the developer, whoever they are, seem like all of these projects are pretty good developers and understand there's going to be issues that you run into, that the cost is going to go up. The woodlark, the two questions were, it sounded amazing to me that even though the specialized elevator was over budget, with all of the other stuff that you talked about that had to be done to the core, the elevator core was less than the cost of the overrun of the elevator. And then the second one, I was just curious as about what they did on the upper floors for the top couple of floors that didn't share a stair. Did they just assume the load was low enough that they could go down and go to one of the lower floors to use the 2 stairs?
Yeah, David, thanks for the questions. For the elevator, I think some of it was the cost it came in was actually some of it was the maintenance of the elevator and the maintenance contracts for like 20 years that once you included that, then I think it was on the order of like between $1 and $2 million that like sort of the delta between them. And so that we didn't have that much of a change. It was more just of the overall cost with redesigning the lateral system. But it just gave everyone a lot of headaches and a lot of very rushed changes where there were kind of the design was coming in and going out to the site and telling them, no, we got to move, this boundary element over here. And so it was a lot of headaches involved, but yeah, it wasn't. I think that was where a lot of the cost was coming in, was in those elevator service contracts over the long term. And it was actually a different elevator manufacturer that they switched to as well as part of that. And then the other one, let's see, Haley, if you could go to that overall image of both the woodlark and Cornelius next to each other.
Oh, the first lead
The
image?
first one that you just had on
Okay.
the screen before.
Yep.
There we go. Oh, wait, no, not
This
that.
one?
That one, yes.
Okay.
So the stair, you can actually see right above the Cornelius building. There's a stair that comes up there. So that actually went up to the 10th story, and so we had a 2-story stair that was just a freestanding kind of addition. It was fully on the Cornelius building, and there's a seismic joint there in between the two, but that was still providing that egress from those upper floors.
Great, thanks.
Good question, David. I just learned a lot. That was great.
I had a
John?
question about finances on these things. You know, like you mentioned on that one there, you show on the slide, there's a $36 million budget. In a situation like a Woodlark project, that makes more sense that somebody would be able to maintain, you know, and understand that there's a budget because it is a historic building and it's inside a infrastructure of the city and everything. But in the situations where we're talking about the motel conversions, do we have an idea as to you know, yes, the embodied carbon and the environmental aspect of reusing the building obviously makes sense, but was there enough? I guess is there enough of a savings there in the reconstruction and redevelopment of all of those things that it balances out financially, especially if you're talking about low income housing or transitional housing. We're talking about trying to, you know, keep the design as cheap as possible. So I'm just curious as to what the numbers look like for those.
I won't speak to Woodlark Hotel, and I can let also Rebecca chime in on some of the hotel to apartment conversions. But if I hop back to the introductory slide on here, the reason why Family Promise and budgetarily works on this project is a few things. One, they have immediate occupancy in a project like this, and so the day that the Family Promise purchased this project, they had over 50 families move into the building, and they were able to occupy and run their business within the building while the jurisdiction allowed for a temporary stay in the building while we got permits underway through and discussed how we would sprinkler the building. And so that was one of the reasons why they were able to make a project like this profitable. You could never have built this many units for 3.7 million ground up. The project also is a project turnkey project, like Rebecca was stating before, and project turnkey is a Senate bill approved process. That's not the exact right word. Go ahead.
Can I help out?
Yes, you may.
Yeah, so Project Turnkey was a statewide initiative
Thank you.
in Oregon, and funding supported approximately 30 projects. Unfortunately, this funding has sunset, so there aren't any future projects currently planned, but the projects sort of were specifically targeted for this type of motel or hotel conversion. And partly it was, you know, understanding that congregate shelters as were used before 2020 were just really not as desirable, and were, you know, had some issues. I'm oversimplifying here, but that funding, you know, was able to take into account some of the things that like deferred maintenance and potential for operations funding as well. So it was applicable perhaps to more areas than some of the other funding sources, which might have limits and constraints on them. From our understanding, we only see one side of the funding puzzle as an architect. So I just want to be clear that I don't know the full story for the funding.
The funding also, yeah, sorry, one thing. The funding never comes in one bucket. It comes in multiple buckets. And so as a result, a phasing of the work, like Rebecca was talking about, accommodates the funding sources coming in buckets and never the same amount.
Well, and I guess, Carl, do you want to speak briefly to the Avalon? I know you had at least a couple of thoughts on that, and then you can dovetail. There's also a question for you in the chat on something structural and not about cost. But I know you had some comments on the Avalon and that as an affordable housing project.
Yeah, one thing also on the Project Turnkey is that because of the success in Oregon, I know Susan Bonamici right now has a bill in Congress where they're looking to see if that's something that wants to go on a national level for doing like similar types of projects across the country. Let's see. Yeah, I think for the Avalon project, go back to the slide there.
Which one? Which slide are you looking for?
The cover
Carl?
one.
Avalon is which one? Is that the San Pedro one?
Supermarket. Yeah, San Pedro. Yeah.
Thank you.
My favorite one.
Yeah, Sarah's favorite. This one. Here you go. Thank you.
All right. I thought it was close to. They had a very significant amount of funds. There was a measure HHH is in Los Angeles that was to fund supportive housing and affordable housing, and I don't have the exact number, but it is something close to, like more than like 2/3 of that was covered from this HHH supportive housing funds. And then I see there's a question also about the 222 West 6th Street, about the floor plates and the floor plan configuration. Yeah, they are very deep units. So one of the deepest unit in the project is 56 feet. But as far as how the architecture team at KFA was making that work with ventilation and lighting, don't have a lot of input on that. Let's see. Sorry, not
You're just
not
a
our realm
structural
of
engineer.
expertise there.
Well, it looks like we're getting right to 6 o'clock here, and I want to make sure we are mindful of everyone's time. We can probably ask one more question if there is one. Otherwise, thank you guys so much for this great presentation. I want to let everyone know that the recording will be available on our website if they missed the first part or whatever. And for those who did come in late, if you want credit, please make sure that your name is correct, because there's like a couple of duplicates. So I'm assuming people used other people's login, logins. So other than that, thank you everyone for coming.
Thanks,
Thank you,
everyone.
Kathy.
Thank
Thank you.
you. Have a good night.
Thanks all.
Thank you.